question is from GATE 2015, Mechanical Engineering paper, set 1, question number 42. A mobile phone has a small motor with an eccentric mass used for vibrator mode. The location of eccentric mass on motor with respect to center of gravity or CG of the mobile and the rest of the dimensions of the mobile phone are shown in the figure. The mobile is kept on a flat horizontal surface. Given in addition that eccentric mass is 2 grams, eccentricity is equal to 2.19 millimeters, mass of the mobile is 90 grams, gravitational acceleration is 9.81 meter per second square. Uniform speed of the motor in RPM for which the mobile will get just lifted off the ground at the end Q is approximately. Let's look at this system. Now, due to the rotation of the motor, eccentric mass will experience a centrifugal force, which can be given as force experienced by eccentric mass, which is the centrifugal force. This can be given as mass of the eccentric mass into distance of this mass from the motor, which is nothing but eccentricity of the mass given as r into angular velocity of the motor whole square. Now for Q to be just lifted, we will have a condition of moment created by the self-weight of the mobile phone about any point. Just for purpose, we'll take point P. So moment created by self-weight of the mobile around P will be just equal to the moment created by the eccentric mass. This is the centrifugal force on the eccentric mass and this is the self-weight of the mobile. So the self-weight of the mobile creates a clockwise moment about P. Let's take it as summation moment about P is 0 because we have to equate these two moments. We can write moment created by weight. First, weight into the distance between point P and CG is 6 centimeters. Let's write 6 centimeters in millimeters because eccentricity is given in millimeters. We'll use the uniformity of units of distance as millimeters. This will be equal to the moment created by centrifugal force Fe. We can write this as Fe into the distance is 6 plus 3, that is 9 centimeters. So we have Fe, which is the centrifugal force, into 9 centimeters is 90 millimeters. Let's substitute the values. Weight is nothing but mass of the mobile phone into acceleration due to gravity. Mass of the mobile phone is given to be 90 grams. Let that be in grams only. 90 grams into acceleration due to gravity should also be taken in mm per second square. So we have 9.81 meter per second square. This can be written in millimeters as 9810 millimeters per second square. Let's substitute it here. 9810 into m into g into this distance 60 mm is equal to centrifugal force is mass of the eccentric mass, which is given as 2 grams. So let that be in grams. 2 grams into this radial distance is the eccentricity between the mass and the motor. This is given as 2.19 millimeters. So this is in millimeters. We'll keep it as it is into angular velocity of the motor is nothing but the unknown. So we'll keep this as it is, omega square into this distance 90. So first thing, 90 on both sides is divided and we get 1. This will give us 30. So we can write omega square, keeping the unknown on one side, is equal to 9810 into 30 divided by 2.19, which is equal to 134383.56. We have to find out omega, so we'll take square root on both sides. We have omega is equal to root over 134383.56. Calculating that in the digital calculator, we have omega as 366.584. Unit will be radians per second. Now we are being asked to find out the rotational velocity in RPM. RPM is revolutions per minute. We know that omega can be expressed as omega is equal to 2 pi n by 60. So from this we can find out n as n is equal to omega is 366.584 rad per second into 60 divided by 2 pi. So this turns out to be 3500 0.616 rpm. Let's mark the correct option. So we have it in option B, 3500. To learn more about the equilibrium equation of moment that we have used in this question, you can refer to the NPTEL video Lecture 10 Beams 1 from the course Engineering Mechanics. It is by Professor K. Ramesh. He is from Department of Applied Mechanics, IIT Madras. I hope this solution will help you clear your doubt. Thank you.